Hey everyone, and welcome back to the channel. Right at the heart of it all, in the big box, is the Kubernetes cluster. On Azure, this is known as Azure Kubernetes Service, or AKS. Think of this cluster as the engine that runs and manages all your microservices packaged inside containers. Now, how do we get our code, our microservices, into this cluster? That's handled by the CI/CD pipeline shown on the left. It starts with dev/ops engineers like me or you writing code. We use Azure Pipelines, a CI/CD service, to automate the process. This pipeline builds our code into Docker container images. These images are then pushed to a central storage called the Azure Container Registry. The Kubernetes cluster, AKS, can then pull these updated Docker images using tools like Helm for upgrading deployments or simply via Docker pull. So, the CI/CD pipeline is how our updated code gets delivered to the cluster in a consistent way. Now, how do users actually access our microservices once they're running in the cluster? That's shown at the top. A client app, this is what the user is interacting with, sends traffic. This traffic first hits an Azure load balancer. This distributes incoming requests across different entry points to our application. From the load balancer, the traffic goes to something called ingress within the Kubernetes cluster. I see the Jinx logo here, which is a very common piece of software used as an ingress controller. Ingress's job is to act as a smart router, directing incoming requests to the correct service inside the cluster. In this diagram, it points to the front end. Inside the big Kubernetes box is where our actual microservices live. I see a front-end service, which likely handles user interactions and perhaps calls other services. It talks to a back-end service, which usually contains the core business logic. These services run inside pods, which are the smallest deployable units in Kubernetes, basically, one or more containers grouped together. A crucial part of this is pod autoscaling. Kubernetes can automatically create more instances, pods, of our front-end or back-end services when traffic is high and reduce them when traffic is low, saving costs and ensuring performance. There are also typically utility services within the cluster, like Elasticsearch, maybe for logging or search, and Prometheus, commonly used for monitoring. Where do our microservices store data? That's shown on the right. We have external data stores. It's usually best practice to keep your main databases outside the Kubernetes cluster itself for better management and separation of concerns. The diagram shows a standard SQL database, like Azure SQL Database, and an Azure Cosmos DB, a NoSQL database. Microservices like the backend connect to these external databases to read and write data. Finally, at the bottom, I see various Azure services that support the entire deployment, often connected via a virtual network for security. Azure Active Directory is key for managing identities and access permissions. Azure Monitor is essential for keeping an eye on performance, collecting logs, and setting up alerts. Azure Key Vault is used for securely storing sensitive information like database connection strings or API keys, which our microservices might need. Conclusion. So, when I look at this, I see a complete picture of a modern microservice deployment on Azure. It leverages AKS for container orchestration, a CI/CD pipeline for automated deployments, Azure networking and load balancing for traffic management, external databases for data persistence, and supporting Azure services for security, monitoring, and identity. This architecture provides scalability, reliability, and maintainability for complex applications. What do you think about deploying microservices this way? Are you using a similar setup? Let me know in the comments below. Thanks for watching, and I'll see you in the next video.